Okay, today we will see second order ordinary differential equation. As you can see, this is the given ordinary differential equation. It is second order with differential operator. Okay, this is our differential, we call it differential operator. Okay, as you can see also here, this is differential operator, and with a constant c after the equality, which shows that this secondary ordinary differential equation is non-homogeneous by nature. And we have to use some trick to solve this second order differential equation, which is non-homogeneous. So the principle we're gonna use is the Euler Cauchy principle. Okay, we use this principle to solve this problem. Okay, this is, as I said before, it is second ODE, and it is what? Non-homogeneous. Okay, so let me use different color, or simply I will use pen. Okay, so it is second order differential equation, but first let us simplify. So to simplify it, let us multiply by y. So if we multiply it by y, it becomes x squared second differential of y minus 4 times x first differential of y plus 6iy equal to c. Okay, we can rewrite this equation as x squared d of dy minus 4x dy plus 6iy equal to c. Or this is x squared, this is first derivative of y. If we derivate again, it becomes second derivative of y minus 4x. The differential of y is the first derivative of y is y prime plus 6iy equal to c. So in this equation, as you can see, we have two different parts. The first one is the homogeneous ODE, and the next part, the whole this is non-homogeneous. Okay, we have homogeneous and non-homogeneous. So first let us solve the homogeneous part, the homogeneous ODE. Let us find the general solution for the homogeneous part. Let us take the homogeneous part, that is the x squared, the second derivative of y, 4xy prime plus 6y, which is equal to 0. Okay, so to solve this, we apply the Euler Cauchy principle. Okay, so assume y is equal to x to the power of m. Okay, then take its first derivative of the y function, which is x to the power of m. So its first derivative become m x the power of m minus 1. So again, let us take the double derivative or the second derivative of this function. If we take the second derivative, that means we can derive the original equation twice, or we can derive this once. Okay, if we derive this once, it is better, so it become m into m minus 1 x the power of m minus 1 is minus 2. Okay, now let us back substitute to the original equation, okay, which is this equation, by the way, this equation. Okay, this equation. If we substitute here, it became x square, the second derivative, which is m into m minus 1, which we already calculated, we already differentiated, which is x the power of m minus 2 minus 4x, the first derivative, this one, m into x the power of m minus 1 plus 6y. So y is given by this, so 6x the power of m is equal to 0. Okay, now follow me, give me your attention, please. So here, as you can see, x square, we have x to the power of m minus 2. Okay, so we have the same base using the exponent rule, the exponent law. We can add. So m minus 2 plus 2 is m into m minus 1. X the power of 2 times x the power of m minus 2 means m minus 2 plus 2. So it becomes x the power of m, because minus 2 plus 2 is 0. So minus 4. Now again here we have x means x to the power of 1, right? So m minus 1 plus 1 become x to the power of m, right? M into x to the power of m plus 6x to the power of m is equal to 0. So here you can cancel, divide both sides by x to the power of m, it will cancel. So as you can see, we already simplified, and our simplified equation became minus 4m plus 6 is equal to 0. But still we have to simplify it further. If we simplify it further, it becomes m square minus m minus 4m plus 6 is equal to 0, right? So this is m square minus 5m plus 6. This is the simplified equation, but we need to evaluate the value of m. So this is quadratic equation, so let us evaluate the value of m, which is minus b, right? Minus b is positive 5, because minus of minus is positive, plus or minus under root b square is 25, minus 4 times ac, a is 1, c is 6, 4 times 6 is 24, over 2a, 2 times 1 is 2, right? So we have 5 plus or minus under root 1 over 2. This is 5 plus or minus 1 over 2. So m1 is 5 plus 1 over 2. 6 over 2 is 3. And m2 is 5 minus 1 over 2, which is 4 over 2, which is 2. Okay, so we know that for such kind of solution, this is two distinct solutions. So this is two distinct real solution. So we can use this equation. So the homogeneous solution, because the one we are evaluating is homogeneous ODE, as I told you before. So it becomes C1 Y1 plus C2 Y2. But Y1 is x the power of M1 and Y2 is x the power of M2. That means x the power of M1 is x the power of 3 and x the power of M2 is x the power of 2. So Y homogeneous becomes C1 x cubed plus C2 x squared. This is the general, therefore this is the general solution for homogeneous part. How about now we get the solution for the homogeneous parts YH. How about the particular solution? Now let us solve the general solution for the particular. Okay, so we know that we're gonna apply to select the particular solution. We need to see the original equation. The original equation is, as you can see, it is equal to C. Okay, it is equal to a constant C. So we apply the basic rule. And the particular solution is equal to C is which means is C is constant, right? C is constant, which is C times x the power of 0, which is 1. We multiply it by 1. We can do this. So it is now convenient to select the particular solution for this kind of equation following the basic rule. Okay, following the basic rule. If we apply the basic rule, y particular become k naught, because it is constant. As you can see, it is constant. So let us take the first derivative of y particular. It becomes 0, right? Because it is constant, k naught. So let's take the second derivative. It becomes 0 again. So let us back substitute this into the original equation. Our original equation is, let me write it again. Our original equation is x squared second derivative minus 4xy first derivative plus 6iy equal to c. Okay, so if we substitute x squared equal to 0, because y second particular is 0, y derivative of the second particular solution is 0. So 4 times x times the first derivative of the y is also 0 plus 6 into sorry, we have no I here. Y is how much? K naught, right? Equal to C, the one we select at the start. So now we left with 6k naught equal to C. So how much is k0? C over 6. So we know that originally we select y particular equal to k0, so which is C over 6. Okay, so the general solution for x square, the second derivative of y, minus 4xy plus 6y equal to C is, or you can rewrite x square d square minus 4xd plus 6i into y equal to C. The solution for this given second order non-homogeneous differential equation is given by y equals y homogeneous plus y particular. So that is C1 x cubed plus C2 x squared plus how much? C over 6. So this is the general solution. Okay, so to say something about the differential operator, the one you see here is differential operator, and this is also differential operator. So for instance, if we say d square y, which means you can rewrite it as d of dy. Okay, so that means d of dy by dx. That means is the second derivative of y, or the second derivative of y. Okay, it is very simple, as you can see. I simplify it like this, then d of dy by dx. So this means when we multiply it by y, when d multiplied by y is dy, right? It becomes dy. This means is dy by dx, or first derivative. Okay, that is all for today. Thank you for following my tutor on advanced engineering mathematics. If you need another videos, if you want to see in the future another videos, please subscribe my YouTube channel for additional videos on advanced engineering mathematics, on other concepts. I will upload soon. Thank you so much. Thank you.